Okay, this is for Algebra 1, and this is transformations on quadratics. Remember that we know it's a quadratic function if it has x squared in it. We know that the graph of a quadratic function is called a parabola, and it is a u, or an upside down u. If you ever turn it sideways, it is no longer a quadratic function. Today we're going to talk about transformations on quadratic functions, and a transformation is just a change. So we've got to be thinking that our original function is usually the parent function, y equal x squared, and we're going to identify changes to that graph. If you change the constant, this is going to be the number at the very end. The graph will go up if it gets bigger. It will go down if the constant gets smaller. If you put a negative in front of your x squared, it's going to make the parabola open down. We often call that a flip. If you change the coefficient, which is the number in front of x squared, it's going to change the width. If you make it a bigger number, it's going to become narrow. You're going to stretch it and it gets narrow. If you make that coefficient smaller, it's kind of like you're squishing it and it makes it wider. So looking at number 1, remember we're comparing to the parent function of y equal x squared. Number 1, we have the new function x squared minus 3 equal y. So that minus 3 is our change. It was the constant, so at the end. And we got smaller, because originally it would have been plus 0. So we got smaller, so that means we went down 3, because from 0 to 3 is a distance of 3. So on number 2, x squared plus 5, we've added a constant at the end, so it went up 5. Remember, we're still comparing to y equal x squared. The constant for your parent function, the constant is 0. The coefficient for x squared is 1. So my coefficient changed from a 1 to a 3. That means it got bigger, which means that my graph got narrow. For number 4, it's 1/2 x squared. That means it got smaller, because 1/2 is smaller than 1. So that means that my graph got wide. If you weren't sure when you had a fraction, take it and make it a decimal. You would go 1 divided by 2 in your calculator. It would show you that it was 0.5. You know that 0.5 is smaller than 1, so it got wide. So we're still comparing to the parent function of y equal x squared. Looking at the first one, there are actually 2 changes. The 5 is your coefficient getting bigger, so that means that it got narrow. The minus 5 at the end is your constant changing. It got smaller, so it went down 5. So looking at number 6, we have 2/3 for our coefficient. That is 2 divided by 3, which is 0.666, going forever. That's smaller than 1, so that tells me we got wide. And then we have a plus 5 at the end. That's getting bigger, so we went up 5. Still comparing to the parent, y equal x squared. This one's going to have 3 changes. The negative is a flip. The 3 makes it narrow. Now, don't consider that to be negative 3. Negative does one thing, 3 does another. You got narrow because 3 is bigger than 1. And then the plus 6 is going to make it go up 6. Negative is a flip. 1/2 here is wide. And, oh, look at that minus 7. It's on the wrong side. You got to bring it to the other side. This should be negative 1/2 x squared plus 7 equal y. So it's actually going to go up 7. Make sure that you move that minus 7 before you start analyzing what it does. If they told you that you were starting with y equal x squared minus 3, and your new one was y equal x squared plus 5, you've got to think about x squared minus 3 is going to be way down here. Plus 5 is way up here. We had to go up 3 to get to the origin and up 5 more. So we actually went up 8. You might want to graph those on the calculator to look at to make sure you get those right. Okay? Okay, that's transformations on quadratics. If you have any questions, come see me during speed.